Good day, ladies and gentlemen. I am Itamar Friedman from Alibaba Israel Machine Vision Lab. I hope you had a good lunch, and I'll try to wake you up. So today, I'm very excited to be here to discuss with you about the present and future of AI creation. Roy Amara, the former president of the Institute for the Future, had a saying which later became known as Amara's Law. We tend to overestimate the effect of a technology on a short term and underestimate the effect on the long term. So I believe this is very applicable for AI. So I have a question to the audience. Let me know what you think. Please raise your hand if you think there is a hype in the news about AI. OK, so it's more than I thought. So it's good. I thought it would be like more than half, even more. So with all the hype about AI in the news, we're very likely to overestimating the AI capabilities as they are today. And I think you heard that in the panel. However, it's very likely that we are underestimating the impact it would have on our future, right? Perhaps on our far future. So let me give you an example, electricity. Faraday's invention and discoveries were truly groundbreaking in the 19th century, right? Yet how much impact did it have on the society of his time? One thing is quite sure. They couldn't possibly imagine what would be the impact on 2020. So I believe this is also true for other type of important technologies, such as GPS. Think about your phone, for example, and about semiconductors. And who knows, perhaps even blockchain. But I'm not going to ask you about that. OK. So machine learning is already in quite a vast use in many products. For example, in Alibaba and many other companies, it's already, I would say, in use in all of the products and businesses. But have AI reached a full potential? I strongly believe not. So in 2012, we witnessed a breakthrough in the field. Neural networks were utilized efficiently on a large-scale dataset called ImageNet. I will refer to that moment as the AlexNet moment. Now, this is very important, because before that, we had a bunch of researchers, I'm among them, that were programming a lot of if and else and things like that in order to handcraft some algorithm. And after that, a small bunch of researchers needed to use neural network to program a lot of those if and else in one neural network that does it for us. So it's very important. And one of the answers, or maybe questions or answers I want to have us to discuss today is what's the next step and how it could help us to empower our business. So despite this AlexNet leap, and many efforts and many efforts invested in this topic, for example, improving the neural architecture itself or improving the learning processes, machine learning had yet to have a scale where any business can employ AI easily. You're probably here also because you're having not so easy time to use machine learning as you can use, for example, web or cloud or something like that. So although many companies are already using this technique, the most advanced deep learning, I would say, is still in the fortune of those that can hire and keep the most relevant talent. And even some of the largest corporates, if not all of them, are having a hard time to take the most advanced deep learning and apply it on new fields, as can be seen, for example, in autonomous driving. So just an example, you can see for those engineers or researchers, you have the AlexNet, you have the VGG, and Inception, Exception, DenseNet, CondenseNet, ResNet, whatever you want. Well, it's a lot of networks that were being developed lately, and this is just a short list. And by the way, I put here a short list of architecture relates to computer vision alone. And designing and training a fitting algorithm per problem is a painstaking effort. So one of the goals of the industry today is to break this boundary. What I mean is what we eventually would like to enable any business to simply define their problem, as in define the input, define the output of their desired solution, and let a machine learning solve all the AI for you by itself. Serious attempts to achieve these goals are already in works. Some would say that more than 20 years already. These days, a subset of this field is called AutoML. Lately, due to the advance of neural network methods, some companies even claim to reach a stage where AI is creating AI. But the truth is that we're at the very beginning of this development. An example of an existing methods used today is transfer learning. I think perhaps some of you or all of you already know it because you're researchers or yourself using it today. It's in widespread use. It's a process where a humanly well-designed network is first trained on an extensive data set, and then it's being tweaked on a new data set, perhaps on a new input or output configuration, in order to solve a new problem. So although it's a good direction, this method is limited in performance and domain transformation. Before describing a second method, I would like to repeat and perhaps confess as a researcher. Neural network creation is a painstaking process. Okay? I think you get to a point where you dream about it at night. So it involves a selection of two families of hyperparameters. The first hyperparameter family relates to the network architecture itself. Okay? And the second hyperparameters family relates to the network training process. With this understanding, the industry and the academic world are currently striving to discover how to automate the process of selecting those hyperparameters. Some would say that in order to achieve this breakthrough, we must first obtain a better understanding of how human learned and human knowledge in general. As Isaac Asimov once said, well, perhaps he wrote it, I didn't see, we are wise enough to learn and know, but still not wise enough to control the process of learning and knowledge. I think these days, we are at the very beginning of starting to control this process, perhaps digitally. Let me give you an example of an AutoML algorithm. This is currently under research in our Alibaba Israel Machine Vision Lab, although it's getting a hot topic, and you can see many laboratories working on it worldwide. With an hyperparameter optimization algorithm, we've managed to automatically design and train a so-called child neural network for each given new problem. Thus, with a click of a button, and with one GPU running for 1 to several days per problem, our child neural network models reach state-of-the-art equivalent solutions for many problems we've tried so far. For example, we tried on the famous MNIST, CIFAR, and ImageNet, as well as SVHN and Fashion MNIST, and more. This is supposedly one algorithm to rule them all, and eliminates the need for months of skilled researchers. Okay. However, it's very important to mention that this method is also very limited. For example, all the examples I gave you that we tried so far, all of them are computer vision classification problem. As I said before, we're truly at the very beginning of this research, discoveries, etc. The drawback of an automated network architecture search is that it's very difficult optimization problem. In some implementation, it could be a combinatorial optimization of billions of possibilities. Each may require a full weight train for evaluation. So for all of you researchers there, something I'm rounding with emphasis I'm putting where you can check out and things can be improved. For example, perhaps you can reach your algorithm